Hey guys, let's talk about solving systems of equations. This video we're going to focus on elimination. This is what we call a 2 by 2, which means it's two equations and two variables. So we have two equations, the top equation, bottom equation, two variables, x and y. So you cannot just solve an equation, for their specific values. You can't solve for x and y and find their specific values if it's just that. You can't do that. We need to get it down to one equation, one variable. So when we can do that, we can do a lot more with algebra and figure out some of these answers. So the way we're going to go from two equations, two variables to one equation, one variable, in this video, we're going to do it by elimination. So we're going to come down from 2 by 2, go to a 1 by 1. Now, with elimination, what you want to happen is either, well, first off, it kind of looks like this. You're going to have your x's, y's lined up. That's always a good start. We want either our x's to go away or our y's to go away. What I mean by that is we like to see, maybe a 7x on one equation and a negative 7x on the second equation. And they line up. You're going to have the same number, but you want one to be positive, one to be negative. So 7x, negative 7x, 23y, which means you need a negative 23y. That's what we want to happen. Now, sometimes, like you're going to see in this first example, our system is already set up and ready to go for elimination. So if we look at this, and we have a negative 2x and negative 3x, those aren't going to eliminate. If you add straight down, you get negative 5x. But if we look at the y's here, we have a 2y and we have a negative 2y. If you combine these two together, 2y minus 2y, you're going to get 0. And that's going to eliminate the y variable. So since these are already set up for elimination, what I'm going to do is I'm just going to add straight down. Add straight down, add my x's, add my y's, add my constants over here. So negative 2x plus negative 3x is negative 5x. A 2y minus a 2y is 0, so don't need to write anything for that. And negative 16 plus 11 is negative 5. And just like that, I went from two equations with two variables down to a single equation with one variable, which is x. Now, we can solve this for x pretty simple. You're going to divide by negative 5 here, divide by negative 5 there. And when I do that, I get x equals 1. So what I've done is I've unlocked some of this here. I figured out one of my two variables. So once I got one equation, one variable, I'm going to head back up. Let's go to the two equation, two variables. Since I have one of the variables, I just need to find the other. So what I'm going to do is I'm going to take this x equals 1, and I need to plug it in either into the top equation or into the bottom. It does not matter which one you choose. Both will give you the exact same answer. So you kind of pick one that maybe you look at and feel like is going to be a little bit easier to do. So I'm going to use this top equation. So I'm going to rewrite this top equation, but anytime I see x, I'm going to plug a 1 in. So right here, I'm going to plug in a 1. So I would have negative 2 times 1 instead of x plus 2y equals negative 16. And all I have to do is solve this equation here for y. So negative 2 times 1 is negative 2. Everything else stays the same. Just want to isolate my variable here. So I'm going to add 2 to both sides. So I have 2y equals negative 14. And then I'm going to go in, divide by 2, and I find that y equals negative 7. So the answer to this system is x equals 1, y equals negative 7. Okay, so this was a very, very basic elimination problem. So I'm going to show you on the back side here a little bit more complex. So a little bit more complex problem. So I have negative 3x minus 3y equals negative 30. Negative 2x plus 7y equals negative 2. So looking at this, I want to look at my x's first. I got a negative 3x, negative 2x. These are not going to eliminate. Look at my y's, a negative 3y and a 7y. You combine those, you get 4y. Neither of them are going to eliminate. So we're going to have to do some multiplication, some changing to these equations. So again, we get that matching up. So we could get like, say a 10x and a negative 10x, something like that. Now, whichever variable you choose, it doesn't matter. We'll all arrive at the same spot. Things I look for is when already the variables are opposites, meaning one's positive and one's negative. I always like to see that because we're going to need a positive and negative here. I like working with that, personally. That's my personal preference. Whereas over here, when they're both negative, this means you're going to have to change one to be positive and leave one to be negative. So I'm going to focus in on my y's. And I'm going to try and think, all right, what's the least common multiple of 3 and 7? Meaning, what do I think I can get these numbers to match up as? A least common multiple, what can I multiply these by so they eventually match up? So 3 and 7, the least common multiple there is 21. So I have to think, all right, how am I going to make this top negative 21y? Well, to do that, I'm going to multiply this by 7. Now let's focus on the bottom. Kind of hard to see that 7. How can I get a 7y to be positive 21? Well, I'm going to multiply the bottom by 3. So when you do the multiplication, this is a common mistake. You have to go all the way through. This 7 is going to be multiplied to the negative 3x, the negative 3y, and the negative 30. Don't get caught and only multiply to the first two and stop. It goes to everything. So I'm going to take this 7 times negative 3x. That's negative 21x. 7 times negative 3y. That's negative 21y. And then 7 times negative 30, which is negative 210. Now I need to multiply the 3 through the second equation. 3 times negative 2x is negative 6x. 3 times 7y is 21y. Then 3 times negative 2 is negative 6. So kind of a stop and checking point is we wanted to eliminate y. So if we look at it, I have a negative 21y, a positive 21y. So this is going to work out great. This is going to eliminate, which was our goal all along. So I know I can keep moving forward. I don't need to go back and fix anything. So adding straight down, negative 21x minus 6x is negative 27x. Negative 21y plus 21y is 0. Negative 210 minus 6 is negative 216. So now I just need to solve for x here. Divide by negative 27, divide by negative 27. You get x is 8. So as always, we went from 2 equations, 2 variables. We eliminated, and now we're down to 1 equation, 1 variable, x. We solved it. Now, in order to get your second variable, your y there, we're going to have to go back to one of the originals. Doesn't matter which one. Plug in this 8 for the x, solve for y. I'm going to use the top equation on this one, so negative 3. Instead of the x, I'm going to substitute in that 8. Minus 3y equals negative 30. Negative 3 times 8 is negative 24, minus 3y, negative 30. Going off the page a little bit there. So I substituted in the 8, multiplied. Now we're just down to basic algebra skills of solving. I'm going to isolate the y by moving the 24 over. So negative 3y equals negative 6. Divide by negative 3. We come to y being 2. And that's another way of solving, this time by elimination. One more thing I want to comment on this video, though, is things you need to be careful of. Is there are special cases when you solve these systems. If at any point you're solving by elimination, or my other video, which is substitution, and say all the x's and all the y's cancel out, and you're left with just something like 0 equals 7. This can happen. This doesn't mean you did anything correct. What you have to think about is 0 equal to 7. Is 7 and 0 the same number? They're not. What this means is your answer is no solution for the system. What that means is when we solve the systems, these are actually lines, and all it means is you have two parallel lines. They never intersect. Whereas with a typical system, what you're finding is you're really finding that intersection. So on this question, the intersection would be at 8, 2, that ordered pair, 8, 2. So if you get 0 equals 7, that is no solution. The other case you can get is you could get something like, say, 8 equals 8. Well, is 8 equals 8 to 8 equal to 8? Yes, it is always, no matter what happens, always equal to 8. What this means is infinite solutions. And what does that mean? Well, graphically, it means you just had a system of two of the same line. They're just overlapping each other, so they intersect everywhere. That was a quick overview of solving systems by elimination.